Today we're going to continue working with solving equations, just adding a few more steps each time. So today we're going to be working with multi-step equations. So in your flip book, we've got 4 problems we're going to take a look at. Number 1, again, our process here is to isolate our variable, and we always start with the term that does not include the variable. So I need to get rid of this plus 5. So to do that, I'm going to do what? Subtract 5 from both sides of my equation. You must be showing your work on both sides of the equation. So when I subtract 5 from both sides, I drop down my 3x over 4. My 5 minus 5 is gone. Drop down my equal sign. 2 minus 5 is negative 3. So now I've got just one term left, but I still have 2 numbers left. Need to remember that fraction bar is like a grouping symbol. It is splitting the numerator and the denominator. The denominator does not have a variable, so that's what we get rid of next. So instead of dividing by 4, I'm going to multiply by 4. So 3x equals negative 12. And then I finish by dividing by 3. So x is equal to a negative 4. Then I am going to check my work. When you check your work, we always need to check it in the original problem. So I'm going to have 3 times negative 4 over 4 plus 5. So 3 times negative 4 is how much? Negative 12 divided by 4 is negative 3 plus 5, which does equal 2. Is what it's supposed to. So I know I did that wrong. If I would have made mistakes here, common mistake would be losing that negative. If I had an answer of positive 4, when I check it, my fraction's going to give me a positive 3, and 3 plus 5 is 8, not 2. I would know I made a mistake and to go back and find that mistake. Number 2. What do you think we would do first with number 2? Carter? Okay, distribute. Okay. It's the first thing I think of when I look at that problem. You have another idea, Kimi? Not going to subtract, because what is the 5 doing to the parenthesis? Multiplying. So the opposite of multiplying is dividing. So we have 2 different options here with number 2. Okay? When we think about what we're doing when we are solving an equation, we want to undo. Okay? That way, the thing that we should do is to get rid of this 5. Okay? So we would divide 5 on both sides. So x plus 3 would equal 4. And then I would subtract 3 from both sides. So x would equal 1. If I were to distribute instead, to start, I would have 5x plus 15 equals 20. And then I would subtract 15. 5x equals 5. Divide both sides by 5 and find that x is equal 1. So you can see either way you are going to get the same answer. Okay. This particular problem, it worked out easy to divide both sides by 5 because of the number that was on the right side. We got a whole number. Okay. So sometimes, depending on the problem, you might work it one way or another. If my 20 would have been, let's say, a 28 instead, if it would have been a 28, when I went to divide by 5, okay, 5 doesn't go into 28. So I could work with that fraction, it just makes it a little bit more difficult. I'm still going to end up with a fraction answer if I had 28 instead of 20, okay? But it probably would have been easier then for me to distribute, had a 28 instead of my 20, okay? Then I would have got a 13 divided by 5, had that fraction as an answer. And you will have some fraction answers. Okay? Answers do not have to be whole numbers. Sometimes students get a fraction and they think they did something wrong. Okay? Fractions are numbers. So again, you've got that option. You can either get rid of that number, divide that number out in front of the parenthesis, or you can distribute it in. Okay? Checking our work, again, you need to check in the original problem, not your distributed problem. So I'm going to have 5 parenthesis 1 plus 3. Okay. So inside my parenthesis, 1 plus 3 is 4. And 5 times 4 does equal 20. These next two problems got just a lot more stuff going on one side of the equation. We're used to having 2 terms on one side of the equation, okay, instead of 4 different terms. So when I look at number 3, okay, what I want to do before I start solving the equation is I want to clean things up. Okay? So, need to remember what it is we're actually doing. So when I simplify, okay, combine like terms, I'm only working on one side of the equal sign. Okay, so we need to remember that. Okay. When we combine like terms, I like to circle things that we can group together. Okay, so we're combining 3B and 6B, so we have how much? We have 9B. Okay, common mistake that I see, so don't write this in, but sometimes what students do, they think, well, we're doing the opposite because we're solving an equation. So they'll subtract 3B and subtract 3B. Okay. We just subtracted 6B on the left side. We didn't do anything on the right-hand side. Okay, so we cannot do that. Okay, when we're combining like terms, we do just that. Okay, we're not working on both sides of that equal sign. I also have my constants to combine. I have a -2 and a -8, which gives me a -10. So when I clean up the left side, I get 9B minus 10 equals 17. Now that I cleaned it up, it's something similar to what we worked with the last 2 days with our 2-step equations. So I start away from the variable, So I'm going to add 10 to both sides. 9b equals 27. And then I divide both sides by 9. B equals 3. So again, step by step, we need to show what it is that we are doing. Again, checking our work, we need to check in the original equation, not the simplified version. Because if I made a mistake when I simplified, okay, I'll check it, it'll check, but it's because I'm checking into something that is not right. So we always check in the original equation. So I'm going to have 3 times 3 plus 6 times 3 minus 2 minus 8. So 3 times 3 is 9. 6 times 3 is 18. So 9 plus 18 is how much? 27 minus 2 is 25, minus 8 is 17, which is what I want it to be. Number 4. Again, I've got some cleaning up to do. Again, think about our order of operations. We should be looking at parentheses first. So inside my parentheses, I can clean up because I've got like terms to combine. So I get 3a minus 3. Everything else stays the same. So now my problem looks similar to what I had in example 2. So again, you have two options. You can either distribute that negative 2, or you can divide by negative 2 on both sides. Okay? Because negative 2 does go in evenly to 36, I'm going to do the division. If you would rather do the distribution in your notebook, that is completely okay. We will end up with the same answer. So I'm ending up with 3a minus 3 equals negative 18. Then I'm going to add 3 to both sides. So 3a equals negative 15. And then I divide both sides by 3 to find that a is equal to negative 5. When I check my work, I have negative 2, and then my parenthesis, I'm going to have negative 5 plus 2 times the negative 5 minus 3. And I'm hoping that that equals 36. So inside my parenthesis, I need to do my multiplication first. 2 times negative 5 gives me a negative 10. So I have negative 5 minus 10, which is how much? Negative 15 minus another 3, which is negative 18. So I have negative 18 times a negative 2. A negative times a negative gives me a positive 36. So just some additional things to work with these multi-step equations. Okay, sometimes we have some distributive property that we could do. Combining of like terms, which is going to clean things up before we start that process of solving those equations.